Thanks for joining me as we begin our Unit 14 materials on units, groups, blocks, limits, and architectural drawing conventions and standards. Sounds like a lot of stuff, but it all welds together and melds very nicely. So let's talk about units. And when I say units, what do I mean? I mean the measuring system that we're currently using. We can look at it like this. Units are the format that AutoCAD speaks to you in when you're asking it about size information. Sometimes units also affect AutoCAD's ability to understand what you're trying to tell it. So in this country, we measure in feet and inches. In other places around the world, well, most every other place around the world uses something called the metric system. But we're most comfortable with the standard imperial system. So when we were doing drawings previous to this, and you saw this drawing, and you saw the number 7.00, what did we imagine that was? 7 feet, 7 miles, 7 light years? Well, no, we just assumed that was 7 inches, right? And the 4.75, same thing. That's 4 3/4 inches, because I probably said that during the course of the instructions too, right? 0.25 is a 1/4 inch. I might have said that. So we've been under the assumption that we're working in inches and parts of an inch, right? And as the drawings have gotten more complex, that really hasn't changed. The radius 0.2 on the corner here, well, that's 2/10 of a what? Yard? No, it's 2/10 of a inch, right? So the assumption has been we are working in inches, and AutoCAD is a tool that lets you draw things in inches, and everything we've drawn so far has been pretty small, so this hasn't really been a problem. Even when we were doing the common fractions here instead of the decimal fractions, that works still, right? We can work with common fractions, number slash number, numerator slash denominator, and type that information in. And then, even though the drawing might have gotten complex, the assumption has always been, though, that these are small objects that have fit on a little 8.5 by 11 piece of paper at 1:1 scale. So, I have to tell you, though, that AutoCAD is not measuring in inches. Yep, that's right. AutoCAD is completely unit neutral. So in the United States, when we type in 1 for the distance, we assume we're working with 1 inch. If we type in 0.5 or 1/2, well, the assumption is that's a 1/2 inch. If we type in 12, well, that's 12 inches or 1 foot. See, in the United States, the assumption is we're working with standard imperial units, the customary system, and whole numbers represent inches, and fractions represent parts of an inch. But that's really not true, because AutoCAD doesn't know it in inches. And in fact, if we were in just about any other country on the planet using the metric system, and you typed in 1, well, the assumption would be that is 1 millimeter. Right, so that is the base unit for technical drawings in the metric system. 12 is not a foot, it's 12 millimeters. And 0.5, well, that's kind of odd. You're not supposed to use fractions in the metric system, but that'd be 1/2 of a millimeter. Right? So, keep that in mind, because AutoCAD's kind of dumb when you think about it when it comes to units. I click, I drag, I type in 1, I hit enter, and we say, well, that's 1 inch. And you know, for what we've been doing, it's been working just fine, so there's nothing really to have to unlearn here. I type in 0.5 for a distance, and that is half as long, that is 1/2 inch. And if I typed in 1/2, because you can type in common fractions like that, numerator slash denominator, and hit enter, you also get 1/2 of an inch. Now, what haven't we had to type so far when we want to specify inches? See, what we haven't typed is the little marks that represent inches, right? We haven't done that a single time, or at least I hope you're not doing that, because either A, it will not work, or B, it is completely useless. AutoCAD doesn't need to see that. It just makes the assumption we're in the United States, these are inches, so why type stuff you don't have to? You're just wasting your time. Okay, so you know what those are. You've seen them before. The double tick, the quote means inches, normally when we write it out, but we haven't had to use that for any of our inputs so far. Okay, so go away. Now, we're not going to always draw little things that fit on 8.5 by 11 sheets of paper. we might draw big things, right? So can we use larger numbers working with this unitless system here and just assuming each number, each whole number means an inch? Sure. So something that's a foot long, I could type in 12 to represent the 12 inches and all is well. But you might be familiar with this symbol, right? It's the single tick, the single quote. And it's on the same key as the quotations. It's the key to the left of enter. This means feet. So this doesn't mean 1 inch. When we see this, it means 1 foot. And of course, 1 foot is very different than 1 inch, right? So I was able to type in 12 to get 12 units to represent 12 inches. I want you to see what happens, though, when I go to type in 1 foot. So if you look on my command line, you see 1 foot. And then I'll hit enter. And then you're going to notice that nothing happens. Nothing at all. 1 foot, 2 foot, 3 foot. See, AutoCAD's not understanding that I want to use feet. So let's talk about how to get it to understand that, because that's a pretty big deal. If we're working with drawings and we're drawing large things, you know, a parking lot, a house, an apartment building, a refinery plant, we don't want to have to convert every single measurement into inches, right? If something's 27 feet, do you really want to figure out how many inches that is? That's ridiculous. So we can ask AutoCAD to work in feet. We just got to know how to ask it. And the way we do that is we work with our units. So down on the command line, I'm going to type in units, U-N-I-T-S, and it will open up the dialog box for units. And it's going to tell us some things about the current drawing settings. So right now the current drawing is set for decimal units, and it's set to the nearest 10,000th of an inch, or 4 places to the right of the 0. Okay, well, what does that even mean? Well, if we take a look down on the status bar at the very end, do you see that we're working with whole inches and then a decimal that goes out 4 places? See, AutoCAD right now, by default, is set to work in whole units and round to the nearest 10,000th. Okay, so as I move my cursor around, those first 2 numbers on the XY axis are changing. Okay, and that's the level of accuracy we're talking about. So that doesn't mean, though, that you can't type in a number with more than 4 decimal places. You could. It's just that units are kind of a funny thing. Sometimes units are important when you talk to AutoCAD. Like right now, we're trying to talk to it in feet, and it doesn't understand feet. So units affect AutoCAD's ability to understand what you're typing, your input. But units are also what AutoCAD's going to respond to you in when you ask it a question. So when AutoCAD talks to you, the response will be in whatever units the drawing is set for. Okay, here's what I mean. Let's go make a fillet. I start the fillet command, and look what it says down here for the radius. It says the radius is 0.0000. Okay, and if I say, hey, give me a 0.5 radius, 0.5. Okay. Now the new setting is set to 0.5. You see over here how we had 0.000. So AutoCAD was talking to you to tell you that, hey, this is the setting that you currently got, and it was going to that 4th level of precision. If you have been using the measuring tools, like distance, and you click from here to here, and then you look down on the command line, do you see the distance it's calling out? 1.0000. It's going to the nearest 10,000th. Right? Why is it measuring to the nearest 10,000th? Well, it's doing that because our units are set to the nearest 10,000th. So go back to units, and let's do this for our distance. For our length units, let's change it to the nearest 100th. 2 places. Alright, so no visible change on the screen really, but look down on the status bar. Do you see how the coordinates are much smaller now? Because now we're only rounding to the nearest 100th of an inch, or the nearest 100th of a unit, I should say, right? Okay, and if I type in F for fillet, I see now the radius, it's talking to me, it's saying it's at 0.50. it didn't add the extra zeros because the units are only set to go to the nearest hundredth. Okay, so sometimes this can be kind of funny because if you aren't paying attention, you might think that AutoCAD's broken. Here's what I mean. Fillet radius 0.375. Okay, 3/8 of an inch, right? 0.375. And I'll throw a fillet on here and on here. And then I'll go back to fillet. And then when I look at the radius, look what it's saying. It's saying the radius is 0.38. Well, what the heck? I just made it 0.375. Why does it say 0.38? Well, if you guess that it's rounding, you guess correctly. Okay? If you wanted to see the 0.375, you'd have to go back to the units, and you'd have to set it for 3 places. And then the next time we run the fillet command, it'll tell you, hey, 0.375. Okay, so units are the way AutoCAD talks to you when it gives you information, either on the command line or in a command, or even with the measuring tools here. And like this case here, changing the units is going to help us to work with the foot mark. All right, so back to the unit dialog. These 2 settings here are going to control length units. These settings here are going to control angle units. What kind of other length units do we have to choose from? Well, how about this? How about fractional units? You know, maybe you don't like working in decimal. Maybe you're more of a fractional person. So if you prefer to work in fractions and you want AutoCAD to talk to you in fractions, then set it for fractional. Go to the nearest 16th of an inch, and when AutoCAD rounds, it will round to the nearest 16th. So if I say, hey, give me a fillet, and what is the radius? It says now that the radius is 3/8 of an inch, 3/8, right? And if you do some distance measurement, how far is it from here to here? Do you see how the numbers on the screen are changing? And they are fractional format now instead of digital format. Right, and if I take a measurement and say, hey, what was it from here to here? I'll get fractions down on the command line instead of decimals. I'll get common fractions. All right, UN units. Decimal and fractional are just going to give you a level of control of how AutoCAD talks to you. You can actually talk to AutoCAD in either one. For example, line 0.5. See, it understands 0.5. I mean, I know we're in fractional units right now. It even says it down here. But that doesn't mean AutoCAD doesn't understand decimals anymore. Okay. I'll go back to decimal using this setting. Using that little the box down there in the status bar. Now I'm in decimal. I'll type in 1/2. See, it doesn't affect AutoCAD. AutoCAD understands that this and this are the same thing. So fractional and decimal, you don't have to switch them to work in between them. It's just how do you want AutoCAD to speak to you. Okay, over here on the right hand side, angle measurements. If we had some angles, how do you want AutoCAD to indicate the angle? Decimal degrees, degrees, minutes, and seconds if we're doing civil engineering or surveying. Radians, surveyor's units with distance and bearing, right? So there's a number of different ways of calculating an angle. And then precision. You know, for a decimal degree, do you want to go to the nearest degree, the nearest tenth of a degree, the nearest hundredth of a degree, the nearest thousandth of a degree? If we're working in degrees, minutes, and seconds, we're going to go to the nearest degree, the nearest minute, the nearest second, the nearest tenth of a second. Okay, so setting these up will be how AutoCAD gives you feedback while you're working. Okay, the other couple of units we have in here, we have a unit called scientific. And scientific units are going to be for exponential notation. So for measurements that are incredibly gigantic, or for measurements that are incredibly tiny. So if we're designing stellar bodies, if we're designing solar systems, I might want to measure them in scientific units. Or if I am designing atoms or subatomic structures, then probably this is a good set of units. I've actually never used these on anything ever, but they're in there if you wanted them. Okay, so that gives you decimal and fractional and scientific units. The other one we want to take a look at is architectural units. Okay, so architectural units. And notice that we can control how precise it is. The nearest 16th of an inch is generally acceptable and good. I'll hit OK. And now look at my cursor as I move around the screen. So something's changed. It looks kind of like on the status bar at your coordinate display. It looks kind of like fractions, doesn't it? Because it's showing you whole inches along with fractions of an inch. But do you see what it's also showing you? It's also showing you feet. It's saying 0 feet, 7.5 inches. And if you go way out, after you go beyond 1 foot or 2 foot, right, it'll indicate how many feet and inches and parts of an inch are in the measurement. So when you're in architectural units, you can actually do this. You can go to the place where you want to start drawing, and you can type in 1 foot with the foot mark, like I just did, and hit enter. And then all of a sudden, AutoCAD understands what that means. Okay, I want to draw something 2 feet long, same deal. 2 feet, enter. And all of a sudden AutoCAD understands what feet mean. So in order to use the foot mark, in order to input large measurements that have feet and inches, you've got to switch your unit format to a format that works and accepts that. Architectural is one of them. Okay, the other one that works with feet, engineering. So in engineering units you have feet, inches, and then parts of an inch in decimal fraction. And again, you can go in there and doll that up. You can round to the nearest 100th of an inch, 1,000th of an inch, or just go to the nearest inch. Okay, but either of these two systems will allow you to work with the foot mark. No foot mark, 1 foot. Okay, if we're in fractional, if we're in decimal, if we're in scientific, and we try typing in feet, nothing's going to happen. 1 foot. Bam. Nothing happens. Alright, so units affect how AutoCAD talks to you when it's giving you information about sizes. Units also affect AutoCAD's ability to understand what you're typing in when you start using symbols like the foot mark. The dialog box is pretty straightforward. On the left hand side you have length units, distance, size, what format, and then what precision level. Over here, if we're working with angles, what kind of angles are we working with and how precise are we working. Now there's a bunch of stuff down the bottom here about insertion scale and lighting. Please don't mess with any of that stuff. It has nothing to do with anything that we're ever going to work on. Okay, so we'll just not pay any attention to that. The precision level in AutoCAD. Well, how precise is it? And why do we have so many levels of precision? Well, the reality is AutoCAD will go 13 places to the right of the decimal point to maintain accuracy. But things aren't manufactured to that level of accuracy. The fact is, something manufactured to a precision of the nearest 100th of an inch is going to cost a lot less than something that's manufactured to the nearest 1,000th of an inch. And something manufactured to the nearest 1,000th of an inch costs a lot less than something manufactured to the nearest 10,000th or the nearest 100,000th. Okay, so the question of precision becomes important a lot of times about manufacturing. how exact do these sizes need to be, because nothing's really perfect. If I want to make something a foot long, well, it's not going to be perfectly 12 inches. It can't be. It's physically impossible. How close to 12 can I be? Can I be within a thousandth of an inch? Or is that not acceptable? Do I have to be within a 10,000th of an inch? And the higher the level of precision, generally the higher cost for production. Decimal input. If you want to make 1 inch, something 1 inch long, well, you just type in 1. Easy. You want something a half inch long, you type in 0.5. You want 1.5 inches, you type in 1.5. And we've done this. You've done a whole bunch of drawings like this, right? This is piece of cake. You're very used to doing this now. Okay, how about when the units change and we want to work in fractions? So on the fractional scale, we've got some options to go to 1/4 inch precision, 1/8 inch precision, 1/16. We can go down further, 30 seconds or 64ths. Okay, fractional input is going to be a little bit different than decimal input. So when we want 1 inch, we still just type in 1. If we want 1/2 inch, we'll type 1/2, just like we would write it out. It gets tricky when we do this, when we do 1.5 inches, because you have to separate the whole inches from the fraction with a dash. If you don't do that, okay, if you have 1/1/2 without the dash, well, 1/1/2 is 11 halves, and that's not the same as 1.5 inches. And if you did 1 spacebar 1/2, well, you know what the spacebar does in AutoCAD? It's enter. So all it's going to take is the 1, not the 1/2. Okay. So this is the thing to make a note to self on. Hey self, if I have whole inches and I have fractions of an inch, I need to separate them with a dash when I'm typing them into AutoCAD. Right? Architectural units. Architectural units are going to be when we are measuring large things. We're doing furniture, rooms, houses, buildings, parking lots, property maybe. Okay? Things you would measure with a tape measure, right? So the level of precision probably depend on what you're building. If we're working on cabinets, maybe we're building to the nearest 32nd of an inch. If we're building the room, maybe we're working to the nearest 1/8 of an inch. You know, framing walls. If we are laying out the corners of the building, maybe we're working to the nearest 1/4 of an inch. So precision level is going to depend on what you're making, basically. In architectural input, 1 equals 1 inch, just like it has all the way through. 1/2, 1/2 inch. 1-1/2, 1.5 inches. When you want feet, though, you're going to have to add the foot mark. Okay, so 1 foot, well, that's the one with the foot plates. If you have feet and inches, check it out. You have feet, foot mark, and then no space, no dash, no nothing, just the number of whole inches. Okay, and then here's the most complicated one, and if you can remember how to do this one, you are made in the shade. Feet, inches, and fractional inches. So here's the feet with the foot mark, here's the inches, whole inches right afterward, and then if you've got fractional inches, then a dash in between the whole and the fraction. Alright, so this is how we do architectural input when we are typing distances and sizes into AutoCAD. Engineering units, kind of weird, I don't use them ever. Scientific units, even weirder. We're not going to worry about them because the 3 that we're working with or have worked with so far are decimal, fractional, and now architectural. We're going to add that to your bag of tricks. We're not designing molecules. We're not designing galaxies. We really don't need scientific units. Remember, down at the status bar here, we have a tool that lets us switch in between the unit settings quickly. That doesn't let you get to all the settings. It just lets you switch from one to another on the fly. That can come in handy. And over in your course pack, one of the pages in this unit has got all that stuff that was in the PowerPoint to keep things straight for you. So entering inches, fractions of an inch, and mixed numbers, whether you're in decimal, fractional, or architectural units, you've got all that information. Put a little flag on that page if you have to go back there. This is helpful stuff to have access to. That leads us to a discussion of drawing setup. And what does that mean? Well, drawing setup just means that before you start drawing things, think about what you're going to be doing and then get the file ready to go. Okay? So the idea is get the file set up before you start working, because it'll be much easier to work if everything's properly arranged when you get started than having to go back at the end and do all this stuff. Okay? So we've learned several things over the course of the last few weeks that all contribute to drawing setup. Today, the big one, units. Okay? So the first thing we should do when we're about to start a brand new file, once we take a look at what we're going to draw, is think about the kind of units you're going to be using and then set the units accordingly. Second thing, limits. Last week we talked about limits. How much space do I need to get the job done? How much space do I need to get the job done? Limits are effectively infinite, right? They go on forever as far as AutoCAD's concerned, and it can give you tremendously gigantic limits, but you've got to ask nicely for it. So we use the limits command to tell it where we want the bottom left corner, and then how much space we need out in the X and Y axes to draw the things we need to draw. The first couple of assignments we've done, 9 by 12, right? Or 12 by 9, 12 in the X, 9 in the Y. Those limits were perfectly fine for everything we drew. This drawing was a little bit bigger, right? It was 17 in the X and 11 in the Y. So we needed to increase the limits in the drawing. This set of cabinets here would require larger limits than the ones that were given by default. We're drawing this little cottage here. Same thing. I need to work with how much space I'm going to require for the building and along with any other dimensions or notes that go around it. So it's important to set those limits up and not treat them like they're not very important. Our next thing we need to set up is layers. It doesn't make any sense to draw everything on layer 0 and then put everything back onto the layers they need to be on afterward. You draw things on the layers they need to be on as you're working. And our last step, textiles. Make the textiles early so that you have them when you want to place text. If you take care of these 4 steps ahead of time, then step 5, draw, you're ready to go. And there'll be no going back to fix things and maybe accidentally skip over stuff when it's time to get the job done.